Okay, quickest video ever on the distributive property, and this is the distributive property of multiplication over addition or subtraction. And if you want to have this argument, addition and subtraction are the same thing to me anyway. So here's what the rule says, and I'm going to ask you for 30 seconds of your time before you go off, because this starts off kind of slow, but look at this. If I have a times the quantity b plus c, it's the same as saying a times b plus a times c. Right? So a times b is ab, a times c is ac. Or, if it was subtraction, it would be a times the quantity b minus c is the same as a times b minus a times c. Okay, so you're not impressed, and you stayed with me long enough, but let's look at this really quickly. Let's take a multiplication problem. So something we know, something simple. Let's take 2 times 2 times 15. Is that okay? So 2 times 15, and see if this doesn't help. 2 times 15, and we know declaratively that that's 30, right? We know for sure that this is 30. So what I'm saying to you is, what if we broke this up a different way and looked at it differently? So we said 2 times, so do this. Instead of writing down the numbers I write down any two numbers that add up or subtract to give you 15 and see if it doesn't work. So what I'm going to do, if you don't mind, is I'm going to take 5 plus 10, if that's okay with you. So take my 5 plus 10 here. And then this is what I'm doing. I'm following this rule at the top, and I'm just going to distribute. I'm going to do this times this, and then this times this. And as I'm talking about this, this is a crucial thing. It's probably the most widely committed error in all of algebra, is that people distribute, but they don't distribute completely. So make sure you distribute completely. And then let's write down what our solution is here. So 2 times 5 is 10, isn't it? That's 2 times 5, that's this 10. And then 2 times 10 is 20, so it's a plus, so plus 20. And 10 plus 20 is 30. Not trying to be funny here, but 30 equals 30. So that worked, didn't it? Okay. Let's try it again using some other. Well, how about this? Let's do this. 2 times, how about 17 minus 2? Can we agree that 17 minus 2 is 15? And if you're wondering, well, why the hell wouldn't you just add these numbers together and get your 15 back? You would. But what if it was a variable? And I'm going to show you that in just a second, so just hang in there with me if you don't mind. And I'm going to distribute completely, because we know that's the most commonly committed error in algebra. So we're going to make sure we're distributing completely. And then going to do our math here. And we get 2 times 17 is 34. And then 2 times negative 2 is negative 4, isn't it? And 30, and if you're wondering where I got this negative 4, because look, this is negative 2 right here, isn't it? So I have 2 times negative 2 is negative 4. And when I do 34 minus 4, I get 30 again. I know. Something about, ooh, ah, clap, clap, clap. Okay, really an important thing to know as we get into this, because we're going to use this same technique backwards to do factoring. So I hope that you're seeing this. All right, you know what? I'm going to try to leave it like it is, but can I just leave you with this little exercise to do? Come up with your own multiplication problem. Something relatively simple. 3 times, I don't know, 8. And then try to break it into different pieces. So 3 times 2 plus 6. Go away. 3 times 3 plus 5. 3 times 4 plus 4. And then distribute completely and see if you don't get the same answer. See if you don't keep getting the answer 24 back. Where does that lead us to? Finally, just leave you with this idea. So now, what do we do here if we have 3 times x plus 5? Now, hopefully, we say, by extension, arithmetic, algebra works on arithmetic, not vice versa. So people are not creating these rules, they're finding them. So we know now that we can just distribute 3 times x and then 3 times 5. And we can simplify this out using the distributive property to get 3x plus 15. So I hope this is helpful. I ask you again, please subscribe to my page if you're not already subscribed. Thanks. Ciao.